Hey everyone, it's the bio theorem. It's been a while since we posted, but we're back. Today's topic is linear equations, but before we start that, today's math pun is how do triangles sleep in a theorem. I don't get it. It's not that funny. Today we're talking about linear equations, specifically vocab, their parts, formulas, and how to solve multiple equations for answers/solutions. How exciting. Okay, first off, what is a line? We define a line to be made of many points going forever in opposite directions. How are linear lines formed? Well, linear in our case means following a consistent pattern. There's some pattern that the points follow that make a linear, aka straight line. Each input gives one output. Think of it like a vending machine. You put in some money and get any drink, but the only difference here is that no drink costs the same, so you'll be paying different amounts each time, maybe for a different or the same drink. Okay, now for the second section. First off, we got slope. For more information, see the link in the description. But a quick review, slope is the incline of a line, aka the steepness. Negative slopes go down, positive slopes go up. There are two ways to find slope. One, the line can be graphed, and the rise/run, basically how many units from one point up down, which is the rise, and left/right, which is the run, to get to the next point. The other way to calculate slope is using the slope formula. Take your points as y values, subtract them, and take the points as x values and subtract them. For example, if I wanted to find the slope for this line, I'm going to subtract the 2 points, the 2 y value points, and then the x values to find the slope of the line, which is 2. Both ways work to find the slope, but it's not the best to use the rise over run method when you don't have the line graphed, the numbers are way too large to physically count, or they look like the pink line shown here. Okay, now next up is the y-intercept. It's the point where the lines cross/touch the y-axis. The 0 will always be the x value of the y-intercept. The x-intercept works the same way. It's the point the line touches/crosses the x-axis. 0 will always be the point's y value. So, like opposites. The y-intercept has 0 as its x, and the x-intercept has 0 as its y. Boring. Next off are the different linear equation forms. First off is slope-intercept form, y equals mx plus b. Y is the output/y value of any point, m is the slope/pattern, x is the input/x value of any point, and b is the y-intercept. B will just be a number, but remember this number is the y value of the y-intercept point. The point-slope form is another way to write out a linear equation. The first y is just a variable y, so just leave it as y. The y1 is the y value of any point, m is the slope, x is the variable, so you just leave it as x. x1 is the x value of any point. I said to leave the variable y and x, not y1 and x1. Just the variable y and x, because if you simplify the equation, you get slope-intercept form. Next up is standard form of a linear equation. X is the x value of any point in the linear equation, while y is the y value of any point in the linear equation. A, B, C are all integers, but make a positive. Finally, you have the parent function for linear equations y equals x. Y is the y value of the point, x is the x value of the point. Think of this parent function as the original linear equation. It's helpful for transformations, which is shifting/moving the line in certain directions. Y equals x is basically saying the y-intercept is the origin, so it's 0. And the slope is 1 because any number when multiplied by 1 just equals itself, which is the identity property for multiplication. If, for example, if we plugged in the point 1, 1, it would be 1 times 1, and then you add that to 0, so it's just 1 equals 1, which is correct. But regardless, y equals x has a slope of 1 and a y-intercept of 0, 0. Now, how do you solve the linear forms? Let's start off with the slope-intercept form. So we got y equals 2x plus 1. Let's identify the parts. 1 is our b, and 2 is our slope. Now we want to find the x-intercept, meaning that any x value when plugged into y equals 2x plus 1 should equal 0. So let's write y equals 2x plus 1 into 0 equals 2x plus 1, aka 2x plus 1 equals 0. Again, we make it equal to 0 because this equation is in slope-intercept form. Also, we want to find the x-intercept, and the y value of the x-intercept is 0. So let's solve. We want to get x by itself on the equal sign, so we gotta get 2x alone. How do we do that? Well, I have no idea. Okay, anyways, we subtract 1 from both sides so that 2x gets alone. The first step in this type of problem is to isolate/get the x term by itself. So we got 2x equals -1. Now we want x by itself since we're solving for x. So both sides get divided by 2 to equal x equals -1/2. The x-intercept is -1/2, 0. Now for this point-slope form, we want to make it into slope-intercept form. We're given the slope and the point. We need these two parts, being the slope and point, to turn it into slope-intercept form. Plug in the pieces, so we get y minus 1 equals 4 times x minus 4. Now for the next step, we need to distribute the 4 to x minus 4 so that we can solve. So 4 times x minus 4, we multiply everything inside this parentheses by 4. Now one more step. In slope-intercept form, being y equals mx plus b, the y variable is by itself. So we need to get the y in y minus 1 equals 4x minus 16 by itself. We get y minus 1 by itself by doing the opposite operation. Let me explain. For example, and this is just a random problem, but if I had x minus 2 equals 4, to get x by itself, you need to do the opposite operation happening to the variable. If you have x minus 2, it's subtraction, so add 2. If it's 2 times x divided by 2, if it's x plus 2, subtract 2, and yeah, you get the point. You have to do the opposite, basically. Returning to y minus 1 equals 4x minus 16, we're going to add 1 to both sides, so we get y equals 4x minus 15, and boom, we have our slope-intercept form. Now for the next example, we're doing standard form. We have ax plus by equals c. So our next problem is 2x plus 4y equals 8, and we want to turn it into slope-intercept form, aka y equals mx plus b. Basically, we gotta get y by itself. First, get all the y terms on one side of the equal sign and everything else on the other. We're going to subtract 2x from both sides because we gotta do opposite operations. So we got 4y equals 8 minus 2x. Now, y still isn't by itself. It's almost there though. We need to get rid of the 4 multiplying itself by the y. So we divide everything in the equation by 4 because we gotta do opposite operations so that y is by itself now. Also, as we're solving these problems, and this is for all of them, we need to do the opposite operation, do it to all sides equal sign. So if you need to add 2, add it to the left side of the equal sign as well as the right. Anyways, we divided by 4, so now we got y equals 2 minus 2/4 x. So let's reorganize the terms so that we're following the correct order in slope-intercept form, even though it's still right. But we get y equals negative 2/4 x plus 2. But 2/4 can be simplified into a half. All the digits we can divide by 2. So if you can simplify a slope, do so. We get y equals negative a half x plus 1. Again, we have negative a half because I simplified to negative 2/4. This is different from the opposite operations thing. Simplifying fractions is like opening a wrapped gift. You take off each layer of wrapping so that you can get just the gift. We want our fractions to be the same way, to be simplified, so that the numerator and denominator cannot be divided by any other number except 1. We'll cover simplifying fractions in another video. Anyways, our next example is x plus y equals 5. It's in standard form. Standard form is ax plus by equals c, where a is positive. X plus y equals 5 is the same thing as 1x plus 1y equals 5. So that's how we know. Now we want to make it into slope-intercept form, so we need y by itself. Do the opposite operation, so subtract from both sides, and we get y equals negative x plus 5, and we're done. Y equals negative x plus 5 is saying y equals negative 1x plus 5, so the slope is negative 1 and the y-intercept is 0, 5. Now what if I want to go from standard form to slope-intercept form? Let's look at y equals negative 5x plus 1/5. Okay, so standard form is ax plus by equals c, so we want whole numbers on all sides of the equal side, and a just needs to be positive, so the coefficient, the number multiplying the x, needs to be positive. X and y, the variables on one side of the equal sign, and everything else, in our case, that's just the non-variables, so 1/5 on the other. We're going to add 5x to both sides of the equal sign because we need to do the opposite operation. We get 1/5 on one side and the variables on the other, and it's easier that way to group like that. Okay, so we get 5x plus y equals 1/5. Now, we gotta make these all into whole numbers. I'm gonna do that. Okay, anyways, so no fractions. We have ax, which is 5x, by, which is just 1, aka 1y, equals c, which is just 1/5, which is something we need to fix because, again, no fractions. So how do we do that? To get rid of the fraction, multiply the entire equation left and right side of the equal sign by the denominator. In this case, we're multiplying by 1/5's reciprocal. To explain our reciprocal, I'll show an example. You have a number, let's go with 6, 7, and yes, I know it's 2026, but whatever. This video was technically being produced in 2025, so yeah. Also, Square Dot told me to do it. Anyways, the reciprocal of 67 is 1 out of 67, and the reciprocal of 1 out of 67 is 67. Same thing with a negative number. Negative 4's reciprocal is negative 1/4 and vice versa. If we have 3 halves, the reciprocal is 2/3, and we have negative 3/4, the reciprocal is just negative 4/3. Anyways, so basically what that's saying is you just flip the numbers around. Anyways, we multiply the entire equation in this specific problem. Some problems don't need you multiplying by the reciprocal, rather you just need to multiply by the denominator, but anyways, multiply this problem by the reciprocal of 1/5 being 5 and distribute that. Now we get 25x plus 5y equals 1 and we're done. Last one. Y equals negative x plus 1. We want to make this into standard form. Ax plus by equals c. Everything in this problem is in its place except our ax. So we gotta take our ax to the other side, add both sides by x to get x plus y equals 1. And we're done. Basically, overall, to solve and switch between these forms, just follow the forms' rules, do the right operations, the right opposite operations, and make sure they match the forms' structures.